Welcome to Modra Technology. I'm Tim Modra. I'm going to give you a talk about the benefits of Creel MT. But first of all, we're going to watch the machine run a little bit. We're actually going to watch it finish a creel. What we're seeing here is the action of our whole system: extraction of an empty, putting it into a winder, picking up the wound package, and placing that wound package into position. And it's actually finished the whole side here, and we'll see the full mobile creel now be extracted out of the area, the loading area. Now I'm going to give you a presentation. I'm going to start with some details about Modra technology. Modra technology has been involved in the development of machinery for the carpet, for the soft flooring industry for about 30 years. We've supplied a lot of products. We started with the supply of specialist sensors for Axminster, for detection of faults on Axminster carpets. We developed a woven sampling machine for making Axminster samples we call Kibby, and we developed a tufted machine which we call M-Tuft. We developed this machine further into simpler machines and faster machines. We worked on machinery for rug production, and also we worked on a machine which was part of our experiments into robotics and automation in carpet factories. We developed a blow-in solution for sample creels for tufted carpet. So Modra technology, through our network of agents and directly, we've sold machinery all around the world. We have in 40 countries 150 customers with over 400 machines. And as all companies do, we try and guess the future. And in considering our marketing reach and what our skills are, we decided that Creel automation offers a really great opportunity for us to develop new products and to solve a problem which has really been a difficult problem for the tufted carpet industry. Back to robotics and automation. We were approached by a company in the United States, and they said, can you help us develop a system to replace our manual method of blowing in yarns into mobile creels? And they had the problem when they were doing simple products, AB, it worked quite well, but when they were doing random thread ups or very complicated thread ups, it was easy for the operator to make a mistake. We developed a system. We put 4 nozzles on the end of a 6-axis robot, and we can blow 4 ends of yarn into this mobile creel here, a bottle creel you might call it. We're blowing 4 ends at a time. 4 are picked from a creel of 16, and we can measure the length of yarn blown in here into the mobile creel. The people that saw this system were quite excited and said, can you develop such a system for production? And we knew that there was problems with the length. We're really limited to a length of maybe 100 or 200 meters with such a system. And despite what we did, there was always a small chance of entanglement, therefore a reliability problem, which would have been had a big impact on a production tufting machine. So 2021, why now? Why is this the time to consider mobile creels and creel automation? There's economic drivers highlighting the need to improve the conventional creel. There's money to be saved in the reduction of waste. There's a need for a reduction in labour driven by the increase in labour costs. And there's a demand also for more flexible manufacture. For example, the need for shorter runs without increasing stock holding. And in the last 2 years, we have all had to consider how can we sustain a business in time of unexpected disruption. There's social drivers highlighting the need to improve the conventional creel. The reduction of waste also is a social driver. And there's an increase in difficulty in finding labour for physically demanding jobs. And then there's the thought of reshoring, meaning increasing our national manufacturing capability and capacity, bringing the work back to our own countries. There's technological changes that have come about. There's been a push in all industries towards automation and robotics. There's a desire and a capability also for the customer to order things online without visiting a showroom or even seeing the product. This challenges the ability to produce smaller batch sizes. Many systems are ready. The upstream and downstream capabilities around the conventional creel are technically ready, but the creel really isn't ready. So, and why Modra? Modra knows machines and robotics, and Modra understands tufting and pattern data. We've gathered existing methods and created a new and advanced package and yarn handling methods to solve this problem. We've got a sales, installation and service presence throughout the world. What will this cost? First of all, we've worked out how to make a solution which is sized to supply one tufting machine. Our fastest system can keep up with an infinity machine. We have solutions between a 4-robot 12-spindle system of $800,000 all the way down to a 1-robot 3-spindle system, about $350,000. And these terms I use, 4 robots, 12 spindles, 1 robot, 3 spindles, are all ways that we configure this system to make it suit the production requirements that you have. Before we look at the solution, let's look at the problem in some more details. The problem with the conventional creel was highlighted with the introduction of servo scroll tufting machines. We've since seen fantastic developments in tufting technology like Infinity, then Colourpoint, Tailored Loop, and from Tufco and Cobble and other manufacturers, we've seen equivalent machines and improvements. And all this innovation has brought creativity, flexibility and speed to the industry. But the creel is okay for level draw and big runs, but there's been no significant improvements for 100 years. Maybe 2 pin positions and some indicators. So the new tufting technologies are a mismatch to a creel from the past. How has this happened? The conventional fixed creel was created to accommodate a person. The heights, the spacing, the openings and the reach have all been designed around allowing a person into that structure to place yarn packages. The creel is big and open, meaning that it is expensive and needs a lot of walking. I measured a creel and I calculated 1,000 needles needs 150 square metres. If we have a need for smaller run sizes, the current creel cannot adapt. It truly is fixed. Has anyone improved it? Yes. Interface run their whole production on mobile creels, but manually load and unload packages. Owners of modern tufting machines want to utilise the capacity that these new machines bring. They want to use colours, patterns and varied constructions, and they want to provide the amount of product the customer requests. The holy grail might be, if you have the yarn in stock, make anything the customer wants right now. Has anyone done it? It's almost there. We have CAD systems, we have sales and ERP systems, and then we have tufting machines already in position. The creel stands in the way. So what do we have to do to solve it? All we need to do is to measure what the tufting machine needs and provide it. Setup checks are predictable, yarn paths are known. Why don't we just measure more accurately? Up until now, there's been a battle between accuracy and effort. So does anyone solve it? Does anyone do this well? Gilbos have a system using their Uniwinder, giving plus or minus 0.5% length accuracy. They also have a creel management system to wind individual length packages and label them, but still the operators have to manually place such packages in the creel. Or we change the rules and we say designers are only allowed to use 4 pile heights, or we bin the variable lengths into 4 package sizes or 1 package size, and the extra material is waste. Waste is bad. Waste is a waste. Actually, it's much worse. Waste pushes the problem to somebody else. Waste becomes a transport, a storage, an energy and logistics problem. It may be I think it has to be our duty to use the input materials for their intended purpose the first time around. Or convert everything into product and turn it all into inventory. Keep it until the customer decides she wants it. But at some point, the holding cost becomes greater than the profit, and some of what remains will never be sold, so it's just more waste. To me, automation and machinery make sense to replace people doing hard, repetitive jobs. And I think, again, we're obligated to use machines wherever it makes the workplace a safer place. I wonder if we'll look back in the future in horror at these current times and ask, why do we make people lift, carry and place things? How mature is the digital transformation in carpet manufacture? On one side we have marketing, sales and planning. On the other side we have tufting machines. Each side is digitally ready, the creel isn't. We've got something to bridge this gap. We picked the best of what was available and integrated it all into one system. Mobile creels, precision winding, integration of CAD and tufting data, and we added some special developments as well, a robotic package handling system in particular that can handle the end of the yarn, and combine all these together and we can automate the loading of the creel. We've developed a modular and scalable solution, a brand new creeling system called Creel MT. This configuration here has a mobile creel in the centre of 250 positions, 1,000 grams maximum per position, and around it we have 4 stacks of spindles, 4 stacks of three spindles each, which is 12 spindles, and we have in the centre a robotic package handling system that can transfer empties from the mobile creel into the winder and full packages from the winder into the mobile creel. So you saw a video of our solution just earlier. We have a creel, a robot head and 3 spindle positions, and you saw the transfer of packages, empties from the mobile creel into the winder and from the winder back into the mobile creel. So I want to compare the conventional creel for variable draw tufting to what we do with the Creel MT. In the conventional creel, you bring packages, full packages of yarn or partially wound packages of yarn to a winder. You prepare the yarn onto packages and you go and place packages in the creel. And often you'll put it on a second position and at the appropriate time then go around the creel and splice all these packages into the yarn connecting the creel to the tufting machine. Then you run the tufting machine. And when it's finished, you'll remove what's remaining in the creel. It could be 10 to 15% waste. What's remaining could be thrown out, or it could go back into stock and be back wound or bit wound and come back the next time it's required. So in this process we have 2 areas of variable effort, meaning the effort here is proportional to the run size, to the amount of material we want, and we have 2 areas of fixed effort. The fixed effort areas are the big problem. Under a certain critical run size, even with 2 pins, it's not practical to keep up. The impact here is a low overall equipment effectiveness. Here's some typical times: 20 man hours to place all the creels and 2 hours to splice in the creel. Let's compare that to Creel MT. With Creel MT we have a winder really, and it can be compared to a winder in a factory, except we actually have very low labour requirements on our winder and quite a unique and simple way of guiding the change of yarns at the winder creels. We load our mobile creels, the mobile creels are taken and they're ready now to be beam spliced to back at the tufter. When the time's appropriate, we beam splice and we run the tufting machine. The scrap is between 1 and 2% and the cores remain with the Creel MT. Whereas in the situation above the conventional, our cores also form part of our scrap. Our variable effort stays the same. Our variable effort to load and our variable effort at the tufter is the same. The big change is in our effort to splice, probably is halved down to 1 hour, and the effort which was placing packages in the creel is completely gone. So we have a tremendous labour saving in our Creel MT system. There's a number of benefits and lots to consider in calculating ROI for a system like this. Independently of each other, a few manufacturers have told me that roughly their OEE of their tufting machines is 40%. And also they tell me that if we incorporate Creel MT, the big impact on it will be actually to increase the OEE at the tufter, because less time is required, the tufter has less downtime because the splicing time is less. So let's explore this a bit. A 2 metre colour point machine is $2 million. Our Creel system, the base system, is maybe 750,000. If we could increase from 40 to 50% our OEE, that represents a 25% increase in performance of the tufting machine. So the value of just incorporating Creel MT could approach the value of Creel MT. It pays for itself in the increase in performance of the tufting machine. But there's lots of other savings as well. There's yarn savings, there's labour savings, and there's space savings. Let's consider the space. The floor space of a conventional creel and a tufting machine. The conventional creel here is 1,630 square feet, about 150 square metres, and it's on 2 levels. Our complete mobile creels for Creel MT to do the same purpose only take up 6% of this area. So let's add into this the area required to load. Let's do it twice and add another tufting machine. What this means is in the area that was the conventional creel, we can actually fit 2 complete systems. Again, what this means is a building that had 5 conventional tufting machines with their large fixed creels now could have 10 tufting machines. So, in summary, we have a new approach to creels for tufted carpet. We have opportunities for tremendous labour saving, material saving, and to increase the short run capacity and capability of your company. Have a look at our website, modra.com, or contact us at sales@modra.com to give you more information about how this process can help your business.